Hello students, welcome to Talk on Civil Engineering. So here we have another question related to losses in pre-stressed concrete. So in this question, he asked to find out what is the loss due to shrinkage of concrete. So and he is asking to find out the loss due to shrinkage in concrete for the pre-tension member, for the post-tension member as per IS 1343 recommendations. Okay, so for this, we need to recollect the formulas provided in IS 1343 for pre-tension and for the post-tension. Okay. So for pre-tension member, IS 1343 recommended the ultimate shrinkage strain has 300 into 10 to the power of minus 3 units. Okay. So this is ultimate shrinkage strain. So in the absence of data, the strain values, if strain values are not present, so no, you can take these values. This is a recommendation of IS 1343. And for post tension, the ultimate shrinkage strain will be 200 into 10 to the power of minus 6 divided by log base 10 T plus 2. Okay. So here T represents the age of concrete at the time of transferring the pre-stress. So these are the post tension members. Okay. The post tension members will be precasted in the factory, and they are stressed in the site. Okay, so there will be a certain age, certain period when the pre-stressing is happened. So that will be the T. Okay, maybe it may be the 10 days, 30 days, or 40 days. Okay, so here in this question, he has given the age of concrete as 10 days. Okay, now let us solve this question. Loss in pre-tension member due to the shrinkage of concrete. Okay, so what is the loss formula? So we know the loss due to shrinkage is ultimate shrinkage strain into Young's modulus or modulus of elasticity of steel. Okay, so modulus of elasticity of steel he has given here. So ES is equal to 210 into 10 to the power of 3 Newton per mm square. Okay, so ES value has given, and ultimate shrinkage strain we need to know. So that will take from IS 1343. So that is 300 into 10 to the power of minus 6. So this value we have taken from IS 1343. Okay, so just substitute these values. So 300 into 10 to the power of minus 6 and 210 into 10 to the power of 3. Okay, so the loss will be 63 Newton per mm square. So this is the loss in pre-tension member for the same question. Okay, so in the question he asked to find out what is the percentage of loss. So for this value we need to calculate the percentage. Okay, so for that we need to know what is the initial stress in the tendon. So in the question, just he has provided the pre-stressing force. So for this pre-stressing force, we need to find out what is the initial pre-stress. Okay, so he has given the initial pre-stressing force has 300 kilonewtons. So 300 kilonewtons, and the area of the cable has given. There are 12 cables are there of 6 mm diameter. So the area of tendon or the wires. So there are 12 wires are there. So 12 wires of 6 mm diameter. Okay. So now the initial stress in wires is equal to P by area of the steel or the wires. So P is 300 into 10 to the power of 3 newtons, and area of the steel is 12 wires are there, pi d square by 4. Okay. So if you calculate this, we'll get the stress around 884.2 Newton per mm square. So we got the initial stress in the tendon and the loss of prestress. So now we can find out what is the percentage of loss. Percentage of loss is equal to 63 divided by the initial stress, that is 884.2 into 100. It will be around 7.13%. Okay. Now let us find out what is the loss in post-tension member. So loss of pre-stress in post-tension member. Okay, so we are going to use the same formula, that is loss is equal to ultimate shrinkage strain into Young's modulus of steel. Okay, but here we need to find out what is the ultimate shrinkage strain as per IS 1343. So ultimate shrinkage strain is equal to 200 into 10 to the power of -6 divided by log base 10 t plus 2. So this is the formula according to IS 1343. Okay, so let us substitute the values we have. So that is 200 into 10 to the power of -6 divided by log base 10. So t in the question he has given as 10 days. So t will be directly substituted in days. So 10 plus 2. So this value will be around 185 into 10 to the power of -6. So this will be in units. Okay. So now substitute the values to find out the loss. Ultimate shrinkage strain is 185 into 10 to the power of -6, and ES value is 210 into 10 to the power of 3, right? And we'll get the loss around 38.85 Newton per mm square. Okay. Now for this, let us find out what is the percentage of loss. Percentage of loss is equal to 38.85 divided by initial pre-stress is 884.2 into 100 will be 4.4%. Okay. So this is how we are going to find out the loss due to shrinkage of concrete. Loss due to shrinkage of concrete in pre-tension as well as in post-tension members. Okay. So I hope you got clarity, and even if here we can compare, the values are same, only the method of pre-stressing or the member is different. The method of pre-stressing, the type of member is different. So here one is pre-tension and another one is post-tension. And if you compare this, the pre-tension member is having more loss compared to the post-tension member. Right. So thank you all.